minus b y hat plus x hat divided by b squared plus x squared to the 3/2 power. Now another thing we should notice is that the cross product is distributive. So if I do x cross y, I'll get a x cross y gives me a z, but x cross x, for the exact same reasons these guys canceled out, is just going to give me 0. So this integral further simplifies mu naught I over 4 pi 0 to negative b z hat b dx over b squared plus x squared to the 3/2. And this will require a trigonometric substitution. And with substitution, well, we almost have the substitution right here. If I let x equal to b tangent theta, then my dx is equal to b secant squared theta d theta, and I can substitute accordingly. However, the bounds I can also change. So when x is equal to minus b, we have to figure out what value of theta we now have. Well, b and b, those are the same things, and we have tangent of theta must equal minus 1, which is exactly when theta is equal to minus pi over 4. Now we can play the same trick for the 0 bound, but tangent of 0 is conveniently also 0. So I can now rewrite my integral. Using my trig sum. Squared theta d theta, and this will actually go to b squared divided by b squared plus b squared tangent squared theta to the 3/2. And we'll have to use a trig identity which states that 1 plus tangent squared theta is secant squared theta. Plugging these in, mu naught I z hat 4 pi integral 0 minus pi over 4 b squared secant squared theta d theta. If this becomes, let's see, the b squared will come out, but it will be square rooted and then cubed, b cubed, and then this will leave us with a secant squared square rooted cubed, secant cubed. But these will nicely cancel out, and these will also nicely cancel out. And so all I'm left with is mu naught I over 4 pi z hat integral 0 to minus pi over 4. I can bring the b out. That's the integral of cosine theta d theta. And this integral, well, the integral of cosine is minus sine, so I'll get minus sine of theta divided from 0 to minus pi over 4. And at minus pi over 4, this thing is going to give me square root of 2 over 2, and at 0 will give me 0, so the final answer for this one is just going to be times so we found this integral, gamma 2, and we can actually, using similar logic, show that gamma 4 is exactly negative this. It doesn't take too much work, so if we consider the integral over gamma 4, we can write it out again. But notice now, script r is pointing this direction, while originally the other script r was pointing this direction. So they will actually perfectly cancel out as a consequence of going through all of those vectors. But you'll still be left with one component. So if I write down mu naught I over 4 pi integral, like I said, dl is now x dx cross the script r vector, which is pointing up, so that is xx hat plus by hat. It will be over the same term, x squared plus b squared to the 3 halves. But if you remember the original integral, it was exactly this, but with a minus sign. This is equal to minus the integral of gamma 2. So we can immediately say that gamma 2 and gamma 3, those contributions cancel off immediately. So now we only have one integral left to do, which is over the final gamma 3. So the integral over gamma 3 is equal to mu naught over 4 pi I times the integral. So in order to do this length, we have to consider the distance, which is now going to be the length that we travel here, is minus y, since the current is flowing down. So minus y hat dy cross the vector pointing in from each of those points. So it's still a distance b apart. So it's going to be x hat b, but it's going to be pointing in, so it's going to be minus y hat. And again, it'll be over a similar argument, so we've seen before, b squared plus y squared to the 3 halves. Now when I do this cross product, this term will cancel and we'll just be left with this term now. But we've done this integral multiple times, once, but negative y cross x gives us a positive z. I'm left with a b dy, b squared plus y squared to the 3 halves, which is an integral we did last time, and we know the result that this gives us. This gives us mu naught I over 4 pi times square root 2 over 2b. So if I want to find a total magnetic field, the contribution of all these elements cancel, leaving just this. Mu naught I over 4 pi b square root 2 over 2 z hat. And the magnetic field is just the sum of these, so bz is just equal to mu naught I over 4 pi z hat square root 2 over 2b minus pi over a.